Hello. Today we're going to talk about imaginary numbers. And some of the things you thought you definitely couldn't do before, you will be able to do now. Okay, let's start with the imaginary unit. I, the letter I, is considered the imaginary unit. I stands for the square root of a negative 1. So as you look at this square root of negative 36, before, we would look at this and think, oh, it's negative, no solution. The one word we're leaving out is no real solution, which means there is an imaginary solution. And imaginary numbers are a set of numbers that exist outside the real numbers. Okay, so here we go. You can look at this as the square root of, and remember we can break it apart, negative 1 times 6 times 6. And if you had a pair inside the square root, that was the same outside the square root. Now, if I pull out the 6's, I get a 6 times the square root of a negative 1. I'm going to replace the negative 1 with an I, and I will call my answer 6i. So 6i is an imaginary number to represent the square root of negative 36. Okay, so how does this I thing work? If I equals the square root of negative 1, then if I square it, that's essentially having a square root of negative 1 times the square root of negative 1. So I can combine those and call this the square root of negative 1 times negative 1. Now the temptation is to multiply them and get a positive 1, but it doesn't work that way because you're under a square root. You have to get it out of the square root before you can do that. So that means these are a pair of negative 1's, which is just a negative 1 on the outside. So I squared is a negative 1. So if you have an I times an I, it'll equal a negative 1. That is huge. Okay, so knowing that, if I have an I cubed, remember how exponents work, that is an I times I times I. Okay, that's I cubed. An I squared, or an I times I, is a negative 1. And so if I have a negative 1 times I, this is going to equal a negative I. Okay, hang on. Did you catch on to that? So I is the square root of negative 1. I squared is a negative 1. I cubed is a negative I. So then what in the world is this I to the 4 going to be? It's going to be an I times I times I times I. And so if I grab a square root of negative 1 times a square root of negative 1, that equals a negative 1. And then I grab another square root of negative 1 times a negative square root of negative 1. Wow. I've got a negative 1 times another negative 1. We know that equals a positive 1. And so an I to the 4th is 1. Okay, hang on. This is crazy. So that means if I continue on and I keep multiplying times I, times I, times I, an I to the 5th is the same thing as an I to the 4th times I. Which means an I to the 4th is 1 times I. And so really, this thing just equals I again. So I to the 5th is just I. I to the 6th is an I to the 4th times I squared, which is a 1 times, we said I squareds were negative 1. A 1 times a negative 1 equals negative 1. I to the 7th is an I to the 4th times I cubed. Again, I to the 4th is a 1 times I cubed was a negative I. So this equals a negative I. And I to the 8 is an I to the 4th times another I to the 4th. Remember, add your exponents to get 8, which is a 1 times 1. And it equals 1 again. Now, do you notice this pattern? Negative 1, negative 1. Negative I, 1, 1. You're going to need to pause the video and just kind of take this in for a minute. This pattern of I, negative 1, negative I, positive 1, goes on forever. So what's the shortcut? What if I was given I to the 45? Well, then what you can do is you can say that what's a factor or what's a multiple of 4 that's closest without going over? I would say, considering this an I to the 44 times an I to the 1. That would make 45, right? Well, that means any power of 4, whether it's a 4 or whether it's I to the 4, I to the 8, I to the 12, I to the 16, they're all 1s. They're all 1, 1 times 1, 1 times 1 times 1, 1 times 1 times 1. And so this I to the 44 is just a 1. So 1 times I, you can simplify that I to the 45 as just a single I. How much fun is that? If you need to take a break, take that in, pause the video for just a second, go for it, do it. Whew. Let's move on. Okay, so what does that mean we can do? That means if I have a negative 2i times 7i, remember, it's multiplying between these. So I can reorder these. I can write a minus 2 times 7 times I times I. So obviously, minus 2 times 7 is just a negative 14. I times I is an I squared, or a negative 1. So a negative 14 times negative 1 equals a positive 14. 14 is your answer. So two imaginary numbers multiplied together can get back to real number solutions. And that's why we're keeping track of these things. You're like, where is this coming from? Believe it or not, this was adapted because of electricity. When you start multiplying different resistances together, you have to keep track of it somehow. Imaginary numbers were born. Okay, I love my electronics. What else can I do? Okay, so I got square roots. Now the temptation is to put these together and multiply them to get the square root of 150. Don't do that. Make one big square root, but split it. Go negative 1 times 2 times 5. Times, you can put them under the same root, that's fine. Negative 1 times 3 times 5. Now, pull out your pairs. Do you notice I have a pair of negative 1s? Okay, those can come out as a negative 1 times. I also have a pair of 5s. So a pair of 5s can come out, that's a 5. What's left? Oh, 2 and 3 are different. I can't put those together. Those are going to have to stay inside the square root as a 2 times 3. So now when I multiply this together, what's outside? A negative 1 times 5 is just a negative 5 times the square root of 6. So again, it's following the same rules as simplifying radicals or multiplying radicals. We're just looking for 2 negative 1s, make a negative 1 on the outside. Or you could think of it as an I square roots of 10 times I square roots of 15, and I times I is an I squared, which is also a negative 1. Either way you get there. Okay, why? Let's put this all together now. We're going to now have the ability to solve an equation like this. So looks pretty easy. Standard minus 48, easy. 3x squared equals a negative 48. Again, remember, I want to see your work, and I want to see your steps. I want to see what you're doing to both sides of the equal sign so that it's easier to read and follow. Divide by 3, divide by 3. X squared equals a negative 16. Now, up until this point, this is where we would get stuck. We'd square root both sides. And whenever you square root both sides, of course, don't forget the plus and minus. Plus and minus, don't forget it, okay? But we'd say the square root of negative 16, you can't square root a negative, you're done. You'd say no solution. No real solution. What can you do? You can solve and say square root of 16 is 4, and you can call this a plus or minus 4, but the square root of a negative 1 is an I. So plus and minus 4i equals x. And that is the imaginary solution. Two answers, positive 4i and negative 4i. That's what we're doing. I'm going to give you a few more examples. I'm going to go kind of quick through them. If you need to pause the video, please do. So square root of negative 6, we've done this one before. It is the square root of negative 1 times 6 times 6. If you wanted to break it into primes, that's okay. But pull the 6 out, times the square root of negative 1. Remember to show your work. And of course, 6 times I. That is the principal root. All right, number 5. Let's take a look at this guy. Again, break it into pieces. The square root of, where's my primes? I got a negative 1. What makes 50? 2 times 5 is 10, times 5 is 50. Okay, then I got an x times x and a y times y. Now, find your pairs. 5s, x's, y's. That's it. But you can take out a negative 1 on its own if you call it an I. So then what's left inside that square root is just the 2. And believe it or not, that's your answer. Okay, let that sink in for just a second. Okay, here we go. 6i times 2i. Well, rearrange it. That's a 6 times a negative 2 times I, which is a negative 12 times I squared. What's an I squared? It's a negative 1. Negative 12 times negative 1 is a positive 12, and that is your answer. Okay. Next, look, I got a 5 out here and a 3 out here. Let's rearrange these. 5 times 3, if you want to call it 15 right off the bat, that is fine. Then I'm going to combine everything into one big square root. So the 24 is a negative 1 times, what makes 24? 2 times 2 times 2 times 3. 8 times 3 is 24? Yeah, okay. 18, what makes that? Okay, we've got a negative 1 on it, times 2 times 3 times 3. Yeah, 2 times 9. Yeah, that makes 18. Good. Let's find the pairs. Where are the pairs? Here's a pair of 2s. That's going to be a 2 on the outside. Don't forget, we have a 5 times 3 that are already out there. What else? We've got another 2. Oh, we got a pair of 2s right here. That's another 2 I get to take out. Okay, we've got a 3 and a 3 here. That's 3 on the outside. And I have 2 negative 1s. Now, I could take them each out as an I and then another I. But if I have a pair inside, let's just take it out as a negative 1. What is left in all of that? The only thing that's left in there is just that back red 3. That means we multiply all of this together. And so we end up with, let's see, that makes a 10. 9 times 2 is 18. That's a negative 180 square roots of 3. Can you believe that? Again, show me these steps. It's writing all this stuff down that keeps a track. That's what I'm looking for. Keep looking at that. And then if you have problems like I to the 29, remember, it's about the powers of 4. 29, it's like Price is Right. What is the closest multiple of 4 without going over? And I would say this I could write as an I to maybe the 28 times one more I gets me to 29. Okay, so because this is a multiple of 4, that's going to be 7 I to the 4 powers multiplied together, or 7 1s multiplied together. 1 times 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 1. We all know that that equals just a plain old 1. So you have a 1 times this last leftover I. Well, 1 times anything doesn't change it. This whole answer is just a single I as your final answer. That's what it simplifies down to. So all these multiplied together. I hope this helps. Rewatch the video if you need it. Go back, take time, pause, let it sink in, start your assignment, go back, watch this video again as you're working. Hopefully that'll help. Good luck. Have a great day.